section 1.1, we're going to start just reviewing with solving equations and inequalities. And we need to define two terms here. So a solution is a number that makes the equation true. Equation or inequality. True. So if I told you I had some number plus 1 equals 5, you would tell me that that number is 4 because 4 plus 1 is 5. So this is a solution. The solution to that equation would be x equals 4. A solution set is when we have more than one answer. So this is a set of solutions. So we have more than one. And we will put them inside of curly brackets here. So if I gave you x squared plus 1 equals 5, so our goal is still 4 plus 1 equals 5. Well, 4 is 2 squared plus 1 will give me 5, but that's also negative 2 squared plus 1 is going to give me 5. So this one has two answers of negative 2 and positive 2. So when you have more than one answer, you can put them in the curly brackets there. So our first example here is 5x plus 3 equals x plus 23. So if we are going to solve this, we have to get x's on both sides. So I'm going to first subtract x from the left-hand side to the right-hand side. And that gives me 4x plus 3 equals 23.
Got 4x plus 3 equals 23. So now I'm going to move this plus 3. I can move that by doing its opposite, minus 3, to both sides. So I get 4x equals 20. What is the last step to get x by itself? Divide by 4. So x equals 5 is my answer. All right, next one is a little more involved here. We have 3 times the quantity x plus 6 equals 5 minus 2 times the quantity x plus 1. So anytime we have a number outside of a pair of parentheses, that is telling us we need to distribute that number, aka multiply that number into all the pieces inside. So 3 times x is 3x plus 3 times 6 is 18. I will always draw the arrows on top so that I don't forget to multiply the 3 into all of the pieces. Okay, it's very common mistake to write 3x plus 6. I distribute it into the first one and forget to do it to the second one. All right, on this right side, I need to take the minus 2 and distribute it in. So negative 2 times x is negative 2x, and negative 2 times 1 is negative 2. Okay, you're going to realize really quick, I like to use colors. I'm a visual learner, so I will use colors to try to help distinguish what I'm doing here. So on this right-hand side, I have two terms that are like terms, 5 and minus 2, that I can combine together. What is 5 minus 2? 3. So 3 minus 2x equals 3x plus 18. Plus, writing in black the whole time is a little boring. And if you can see anything about me, I'm not boring. Okay. All right, so now we're going to get our x's on the same side. So currently I have a negative 2x on the right-hand side. If I want to get rid of it, I do the opposite of plus 2x. x. When I do to one side, I do to the other side. Other side note about me, I teach teachers how to teach. So there's a lot of times that I will talk through very thoroughly the steps and concepts just to make sure that you truly do understand before I move on. So if you're like, why is she taking so long to solve this problem? I know how to do it. That's why. So just bear with me. 5x plus 18 equals 3. And then I need to get that plus 18 to the other side. So I'm going to subtract 18 to both sides, leaving me with 5x equals 3 minus 18 is negative 15. And my last step is now to divide by 5. When I divide by 5, I get a final answer of negative 3. Now, you can always take this answer and plug it back in to make sure that it works. Tell you it does work. I have the answer here. It is correct. Good so far? See a few pencils still going, so just give me I'll leave it there for just a second. Okay. If I ever flip too fast and we're not done, either ask me to go back or do know that the PowerPoint with the full solution is posted to Blackboard. All right, next one, fraction. We have x plus 1 over 3 minus x over 4 equals 1/2. So generally, I throw in a fraction and people are like, oh, I hate fractions. I don't want to work with fraction. It's really not that bad. There is one step that we can do, and it will clear out the entire fraction. So what we need to do is we need to find the least common multiple or the smallest number that all of these can multiply up to. Okay, so we're going a larger number that 3, 4, and 2 all have in common. 12. All right, so the least common multiple is 12. So what do I do with that? What I'm going to do is I'm going to distribute 12 into the problem. So I'm going to write it out just so you can see what I'm doing and how I'm getting each step here. So I'm just going to write the 12 is being multiplied by each piece. And then I'm going to show you how it simplifies. So when I have a multiply and a divide here, I can reduce this here with the division first. So what I can do is I can look at this and say, okay, this is 12 times the x plus 1 and then divided by 3. I can do 12 divided by 3. I can work with that number piece first, and that's going to give me 4, which is then going to multiply into x plus 1. Okay, and then I can do this next one here. 12 is multiplied by x, but then divided by 4. So if I do the numbers, 12 divided by 4 is 3, which is then going to multiply by x. And this one's a little bit easier. Half of 12 is 6. Or 12 divided by 2 is just 6. So then this looks like what we just did on the other problem, where we're going to now distribute. So 4x plus 4 minus 3x equals 6. Okay, I can combine these terms here. I have 4x, and you always want to make sure you look at that sign in front of whatever you're combining. So that is 4x minus 3x, leaves me with 1x plus 4 equals 6. Go back to a darker color just in case that's hard to see. Subtract 4. Try not to write at the bottom because I realize people in the back have a hard time seeing. So 1x equals 2. Oh, I'm done. X equals 2. Doing okay so far? All right, so the last thing we can do with equations here is take an equation and solve it for a different variable. So I have y equals mx plus b. That is the equation of a line in slope-intercept form. So it's asking us to solve for m. Well, currently, m is attached to x. So I can't do anything with that piece. It's going to stay where it is, but I can get rid of the plus b. So in order to get rid of plus b, I'm going to subtract b from both sides. So y minus b equals m times x. And now I am left with the mx term by itself. So now I can get m by itself by dividing by x. So y minus b all over x is equal to m. Questions on equations? Okay, so now I'm going to look at what inequalities are. So an inequality throws in symbols like greater than, less than, greater than or equal to, less than or equal to. Now, when I was taught in high school, I will date myself here, back in probably 2001, we were just told if you multiply or divide by a negative, you have to flip the sign. We were just told that rule and you had to memorize it. Were you told that rule and just told you had to memorize it? Okay. Were any of you actually taught why? Okay. This is what I do now. I go back and I take a concept that you've been told and actually teach you why that rule is in place. Okay. This was part of what I teach when I teach my teachers. So I go back at any point in time when there's just a rule. I'm not just going to tell you the rule. I'm going to show you why the rule exists. Okay. Do we all agree that 4 is greater than 2? Yes. Okay. So what happens if I multiply 4 times -2 and 2 times -2? So what happens if I multiply both sides of this inequality by a negative number? Well, I get -8 and I get -4. Which one is bigger? -4 is bigger. So what I started with was 4 is greater than 2. And what I got now is -8 is less than -4. Okay, the same thing is going to happen when I divide with a negative. We're going back to that 4 is greater than 2 statement, but now I'm going to divide by a -2. So 4 divided by -2, -2. 2 divided by -2 is -1. Which one is now the larger number? This one. Okay, so what's happening is when you're multiplying or dividing by a negative number, you're in essence flipping which term is bigger or smaller because you're multiplying by the opposite value. Okay, so anytime I can go and show you something like this as to why that rule exists, yes, you still need to remember the rule, but sometimes seeing an example makes more sense as to why that exists. All right, this is a table that is in your book. You do not need to copy it down. You do not need to memorize it. Anytime you work on homework or a test in my class, it's open note. Okay? I'm not requiring you to memorize this and know that if I get this interval form, it must look like this, it must look like this. That will be the answer, but you don't have to have it memorized. Okay, so this table is in section 1.1 in the text. So you can pull it up in the book. Don't remember if I know, page 6. So if you go to the e-text and literally type page 6, it will take you to this table. So when we graph what are called inequalities, we have some options here. They can be compound inequalities, which means I have two numbers that are my kind of these important points, or I just have one number. So this is just a single inequality down here, and they're graphed differently. Their answers are written differently. So depending on what I have, it's going to show differently. A single inequality is just a number that I'm going larger or smaller than. It could also be greater than or equal to, less than or equal to. The key difference is a less than or a greater than get an open parentheses symbol. It's considered an open value. I cannot use that exact value. If I'm saying I want a number less than 3, 3 is not less than 3. I can't use that value. It has to be a number smaller than it. Versus, if I do the equals to piece, we use a square bracket, which is saying you can include this value. So if I say I want a number less than or equal to 3, I can include 3 because 3 is equal to 3. And then any number less than that as well. Okay, depending on our inequality determines how we then graph our solutions. If we want numbers less than 3, I'm going to plot that value and shade to the left because the numbers less than 3 are to the left. This is my left, that's your left. Left. Greater than are going to be to the right. Compound are going to be between. Okay, so let's solve some of these and then we can come back and talk about how we know what we're going to graph here. All right, I'm going to give you an interval. The interval is from -7 to -4 in parentheses. So how would we graph that? Well, one option is I could literally go to my table and say, which one is that? Oh, that's this one right here. Okay, how did I graph it? Left number, right number, parentheses, shade between. So -7 to -4. If there's parentheses in the interval, there are parentheses on the graph, and I'm shading between. This is saying I want numbers between -7 and -4. If I want numbers between there, I go -7 is less than x is less than -4. I want my numbers to be between -7 and -4. Okay? I have these memorized. If you get stuck again, you can always go back here and say, oh, how did I write that again? Oh, it's this one. It's gonna look like that. Okay, I'm going to give you the graph. 0, 1, 2, 3, 4. I'm going to put a square bracket on 1 and an open parentheses on 4, and I'm going to shade between them. So I'm now giving you the graph this time, and we're going to find the other two pieces. All right, so I am between -1 and 4. And +1, not -1. I'm sorry. Please, if I ever make a mistake and I don't catch it myself, correct me. And then I just carry over the symbols. So it's a square bracket on the 1, a parentheses on 4. It's going to look similar over here, 1 less than x less than 4. But because 1 has this square bracket on it, I need to add the equals to piece to it. So the only difference is if it's an equals to, you get that square bracket piece and you put that little extra line underneath. Yes. This one? On the actual PowerPoint? On the answer key one or on the blank one? Okay, so the notes, it's on the blank one. So I think I added it in after I had done the notes. So just know that it's in page 6 of the textbook, or you can look at the blank page, the blank notes as well. Yeah, sorry about that. All right, so this last one, I'm going to give you the inequality to start with. It's not what I wanted to write. X is greater than 2. All right, so this is a single inequality. There's only one number. So if I look down here, I can find X is greater than, A and B are your numbers. A and B equal numbers. So X greater than a number. I'm working with this one down here, so that's how I'm going to write it. So, other way to think about it, here's 2. Numbers bigger than 2 are 3, 4, 5, this way, right? So I know I'm going to shade this way. And it's not an equal to, so it's just going to get a parentheses. So leftmost value is 2. And then it continues on forever and ever and ever to infinity. Anytime you write an infinity, you will always put a parentheses. It does not matter what symbol is anywhere in the inequalities, parentheses always goes with infinity, because infinity is just a number that keeps going and going and going. You can't close it off. Questions on that one? Okay, so now we're going to solve some of these. So we have 4 times the quantity y minus 3 is less than 3 minus y. So we're going to treat everything the same as what we did before, except for the fact that if I ever multiply or divide by a negative number, I have to flip the inequality sign because it is changing which side is actually the bigger result. So start with distributing here. 4y minus 12 is less than 3 minus y. All right, so I will, let's see, add y to both sides. So I have 5y minus 12 is less than 3. I'm going to add 12 to both sides to get that over. 5y is now less than 15. Dividing by 5. So y is less than 3. Now, depending on the problem, it may be fine to stop there. They may want you to graph it. So you plot your number, 3, and we want numbers less than 3. So that's to the left. The way I think of this is this symbol, this less than symbol is like an arrow. If I make it an arrow, it's pointing to the left. So that is the way I'm shading. Okay, the interval would be I start at negative infinity and I end at, 3, not 2. Next one, x minus 2 is greater than or equal to 2 times the quantity x minus 5. All right, so I'm going to distribute on the right-hand side. 2x minus 10. And I know a lot of people get in the habit of always moving the x to the left-hand side. So if I want to get rid of this 2x, I'm going to subtract 2x from both sides. So I have negative x minus 2 is greater than or equal to negative 10. All right, so add 2 to both sides. Negative x is greater than or equal to negative 8. If I divide by negative 1, that is going to switch the sign the other direction. So x is now less than or equal to 8. Okay, I'm going to show you a side note over here. If I had instead back here subtracted the x this way, I'm going to show you another reason of why this happens. So negative 2 greater than x minus 10. Add 10, add 10. 8 is greater than or equal to x. Okay, these are equivalent. It's just that sometimes we don't like to read it this way. 8 is greater than or equal to x, kind of counter thought, right? Usually we think of like the x first, okay, numbers less than or equal to 8. So what they're doing in the end is literally just taking this whole thing and flipping it over. So flip the whole thing over, x less than or equal to 8. So the symbol is still pointing towards open the 8. I just put the x on the other side. So that's another reason why when you divide by that negative, that switch is happening. Okay, so I would find 8. I want numbers smaller than 8, but I can include it. So I'm going to do a square bracket this time. So negative infinity to 8, include it. All right, so x over negative 4 less than 5 over 2. So x is currently being divided by negative 4, which means I need to multiply both sides by negative 4. I am multiplying both sides by a negative, so I'm going to turn the sign to face the other direction. 5 times negative 4 is negative 20, divided by 2 is negative 10. So final answer, x is greater than or equal, or sorry, greater than negative 10. So I'll find negative 10. We want numbers greater, so to the right, and then I'm going to open parentheses. So open parentheses, negative 10 to infinity. Yeah. You still have to deal with the negative then. Yes. We left off with inequalities, and these are now called compound inequalities. So compound inequalities are going to have two symbols, and your x is going to be in the middle there. So we're going to treat them similar to the other ones. It's just that instead of having a left and a right, I now have a left, a middle, and a right. So whatever I do to any one section, I have to do to all three sections. So I have negative 8 less than or equal to 3x minus 5 less than 7. So we're going to work with the middle to solve for x. So it says 3x minus 5. So the first thing we're going to do then is add 5 to both sides. So when I don't understand what I said that it was even close to Siri. It goes off all the time when I teach math. I literally, it's the weirdest thing. Okay, let's see. We got -3 less than or equal to 3x less than 12. And then now we can just solve for x by dividing by 3. And whatever I divide any section by, I have to divide all 3 sections by. So divide all of them by 3. -3 divided by 3 is -1. 3 divided by 3 is 1x. And 12 divided by 3 is 4. So what this is saying is x is any number between -1 and 4, including -1. So I can include -1, but 4 is open because it is just a less than symbol. And then I can graph it the same way. So 0, -1, 1, 2, 3, 4. Put the square bracket on the -1, the parentheses on 4, and I would shade in between. All right, so one more like this. -4 is less than 5x plus 6 is less than or equal to 21. So we're going to do that same thing, break it up, and work with where your x is located in the middle here. So I'm going to get rid of that plus 6 first, subtracting 6 from both sides. So -10 is less than 5x is less than or equal to 15. And then we can divide by the 5 that's in front of the x to get, let's see, -2 is less than x, less than or equal to 3. So this one is, oops, I put the bracket on the wrong side. -2 is open. 3 is the one that's closed because it's the one that has the equals to piece. So then -2, -1, 0, 1, 2, 3. We're between -2 and 3, including 3. So hopefully you can kind of see that how the one translates into the next translates into the graph. All right. So an application problem says a company has fixed costs of $36,000 and it costs $10.40 to make each mechanical part. The part then sells for $15.20. What is the break-even point? I'm gonna take a guess and say, Ashley. Yes. No, you're fine. All right, so this is a concept we're going to talk about a lot in this class as far as revenues and costs. So your costs is money that goes out. And anytime you have a cost equation, a lot of times, oops, it's fixed. Okay, I'm clearly not spelling today. F-I-X-E-D, fixed plus variable cost times X. That's how your cost equation is always going to work. Okay, so there's fixed costs involved in having a company. So things like rent for your building, employee salaries, stuff like that. Those are costs that are going out that are fixed each month. Your variable cost then is how many parts you're making. So your cost equation here is going to be 36,000 plus $10.40 X, because each additional part is another $10.40. Okay. Revenue in most cases when we are working with it is just the sale price of the item times X. It says the part sells for $15.20. So revenue is 1520X. Anytime they ask for a break-even point, they are asking for when does cost equal revenue. So your goal is to figure out how many items I need to both make and sell in order to break even. That's the middle point. Okay. If I make and sell less than that, I'm going to lose money. If I make and sell more than that, I will then earn money. So we can just set it up as 36,000 plus 1040x equals 1520x. And then this is a problem just like what we did. So I'm going to get the x's on both sides. I'm going to subtract the 1040x. So 36,000 equals $4.80 x. So then I can divide by that $4.80. And I will get 7,500 items. Okay, so anytime, if I sell exactly 7,500, zero, everything zeroes out. If I sell more than that, I'm going to earn money. If I sell less than that, I'm going to lose money. Make sense? Okay. Consumer price index is a measure of the average change in prices over time from a designated reference period. It's kind of like an easy way to figure out how inflation has impacted prices. So if I give you a price back in a certain year, you can then figure out what it would be worth today based on inflation. So if a price changes parallel to CPI, what would a car that costs what would a car cost in 2016 if it was sold for $10,000 in 1999? All right, so this is a completely different kind of setup for a problem. What we're going to do is we are going to compare 2016 to 1999. So what I do is I create a little label on the side here just so I know how I'm going to set this up. So it's asking me, what would the car cost in 2016? So I don't know what it cost in 2016, but in 1999, it was $10,000. And then over here, I have values for 1999, according to the Consumer Price Index, and for 2016. So in 2016, it was 241.7. In 1999, it was 156.9. Okay, so it's still a linear equation. We still have a single x, and we have to solve for x. It's just that we have fractions instead of like this string of numbers. Okay. Does anybody remember how you solve a problem where you have a fraction equal to a fraction? Cross multiply is the quickest way to do it. All right, so I'm going to multiply x times 156.9. So 156.9x equals, okay, this is freaking out on me. Okay, and then if I take 10,000 times 241.7, 241,700. And then I can divide by the 156.9. And when I do that, it's not going to come out exactly perfect, but I will round to the nearest cent because it is money. So $15,404.72.